Hello my friends, and welcome to Untitled Electronic channel, and Uncle Misha is with you today, and we again looking at some dollar store miracles today. And what we have is like a flat power bank which claims to be 2500 milliamp hours. Well, well, as usually we know this is joke or junk or wrong. I don't think there is anything really special here. They recommend you to charge pack fully for 2 hours. Sure, of course. Okay, so the main benefits of this thing, that is slim. So let's take a, if actually this is 2500 or whatever they claim. And also let's take a look what's inside. Oh, I hate this kind of... Oh, wow. Packaging. Oh, this one doesn't really cooperate. A little bit cooperates. I really butchered it. Junk. Okay, so it actually does not feel too bad. Plastic is nice. Okay, so model number is 2639 466. Capacity 2500 milliamp hours, 5 volt, 1 amp. No, whatever this junk is, I'm wondering if this is a joke. Okay, just first thing is how easy it is to open. It is easy to open already, tell you. I can just use my nails. Maybe not. Maybe I need some appropriate tools. Like for example this guy. First try this guy without too much of a destruction. Not working. Let's use this guy. It is working. I'm super curious to see what kind of battery is inside. I'm also super curious to see, of course guys, before powering this thing up, I'm gonna take it apart. Ta-da! That's interesting. This thing is 9.25 watt hours. Interesting. Okay, let's just... it's glued. Are you kidding me? Are you glued? Just carefully try to lift it. It is glued. Oh, just... Okay, that sucks. We just, do this then. Okay, it looks a little bit better than I thought. Okay, so what do we have right there at first? Let's take this pokey thingy. Not metal, it's not gonna use metal. So we obviously have our most ubiquitous chip over here, which is like in every single charger everywhere. Also we have this little guy over here, which is protection chip. This is charging controlling chip, so this is good. So we have also our induction coil for a boost converter, and that's it. I'm curious if this cell has any protection in it, or this is protectionless cell, because protection is right there. This little U2 chip is a protection chip. Am I right? I'm curious how they solved the problem with a light leak. So they made this foam kind of wait. Oh no, it goes in here. Wow. It's probably very thin plastic, that's why. So yeah, you don't really see it here, but if this goes in here and those little slots, so there's 4 levels of charging, and we have 3 levels of charging here. So it's charged, it's actually charged. So yeah, I don't really gonna mess up with this battery, because no matter what, like even if it has 500 milliamp hours, it's still pretty beefy. So judging by marking, this is 2500 milliamp hour battery. Not sure if this is true or not. That has to be verified. So yeah, so we're gonna do what we're gonna do. We're gonna discharge this guy, then we're gonna recharge it back in and gonna see. Then I might just desolder the battery out of here, and just charge it with my charger and see how that's gonna fly. So, but I mean that charge controller here doesn't look too bad. First of all, they have this beefy trace, which say they try to reinforce with a little bit of solder. I think does it look like it, or they just forgot to add solder mask? I don't know. Anyway, so yeah, the tracks are here pretty beefy, so that's actually pretty good. Despite the fact that they mentioned 1 amp, maybe it can do actually more than 1 amp, which is something we would like to check as well. We can actually check this right now, because this thing is charged. So let's bring our favorite friend here, is Drock battery or USB power tester. Here we are, so power load I mean. So 5 volts. Let's just reset this thing. It doesn't really matter. And then let's just crank it up. So let's make... Okay. Okay, 1 amp and a bit. 1.2. Right, okay, 1.2. So it is actually cuts out at roughly 1 amp. $127, 1 and the 1.3. So voltage is actually dropping. Okay, well that's not good, 4 volts. Alright, so we know about 1.3. So 1 amp sounds like a legit. 1 amp sounds like legit value, and we already discharged this little guy substantially. Okay. I still do not see if this cell has a protection, additional protection, because what they could do, looks like one of those laptop cells that I have salvaged. This is pretty much the same form factor, or the cell phone battery kind of form factor. But those guys, they have protection. Each individual cell has protection. Maybe laptop no, because that's supposed to be BMS in the charger, in the battery, supposed to take care of it, but still. Let's take a look. Okay, let's try to pull this battery out first. I'll do it slowly with this. Oh no, it's not really that badly glued. Yeah, that's good. Those guys are smart. They decided not to glue it too strong. It's probably just one spot, some kind of foam. Yep, it's just a little bit of foam. It's no big deal. Almost there. Here we are. We can reuse this foam later. Yeah, it's really sticky. Okay. You know what? I may be wrong. It doesn't have a protection actually. Not wrong, right? I mean, I thought it has. No, it doesn't. I mean, I'm gonna do want to remove all this and just cut it, because looks like there is this is the seal of the cell, and on this side there is a seal of the cell. There is no extra, like there is no extra PCB right there. Yep. No, there is no extra PCB. No, nothing there. This is just an insulation. Okay, so yes, so this cell doesn't have a protection, so yeah, you have to use it with either this device or this tiny small protection devices if you want to charge it without a BMS. So is this me who scratched it? A little bit, that's good, it's no big deal. Cool, so yeah, so what left is to actually verify what's the capacity of this of this unit to see if they're lying or not. It's kind of interesting that they have separate in, so if you want to use it for a project, you can just solder the wires right here and have to like fiddle with it. That's actually nice. The switch is to check the battery level. Again, that's the function of this this charge controller. Yeah, there is no extra extra electronics right here, so this controller does a lot of jobs. So it's a boost voltage, it does this charge thing, it makes sure this thing is charging properly, is the proper current. This little guy makes sure there is no overcurrent and short circuit protection, and I think overcharge as well. Alright guys, so after running several charge-discharge cycles over several days, I had figured out or measured the capacity of this battery as 1900 mAh. As you see, it's not as bad as I thought it would be. So it would be like 500 or something to this extent. Turned out to be it's much better, so maybe it is quite capable. So in order to do that, I had to desolder it. This guy seems to be operational, so I just unsolder it in order to properly charge-discharge without any interference. Also, I would like to probably reverse engineer and quickly see how this little charge controller is designed. So yeah, it's not using the batteries, sorry, it's not using the battery management circuit that I thought it would. So it's completely different circuitry. It's using IP5303, so it's completely different a charge controller than TP4056 that I thought at first it uses, and the battery protection circuit is completely different as well. So I'm gonna post schematic and we're gonna go through specifics of this particular charger. I'm gonna reverse engineer it, and yeah, I'm gonna talk about how it works. So one thing I have to note, that during a discharge, this thing got really hot. I didn't have any temperature probe in order to actually measure it, but this side of the board was really hot to touch. I couldn't hold my finger here more than like few seconds. So that's yeah, this is something to think about, because maybe I need to add a little bit more heat thinking on this side. Not sure what I have to do, but obviously over here, if you, I think it goes like this. Obviously over here there is not much space, right? Not at all. So this side will be really hot. Yeah, so maybe that's okay. Also, I think this chip has thermal protection, so if something goes haywire, it's supposed to be shut down. And the current was only 1 amp. This thing was drawing 1 amp. So, by the way, I'm not even sure what the heck happened to this guy. 1 amp is nothing. It's supposed to be capable of like, I don't know, 10 amps or something. Maybe 5. Yeah. Anyways, so yeah, this thing was heating up quite substantially, so I'm not sure what will be the side effects of this over long term, but short term it was working fine. Didn't connect it to any of the USB devices like a cell phone or anything like that, just to see if it's properly capable of proper charging of modern cell phones, because sometimes if you connect it via USB-C, it behaves weirdly. So this old charger may only, charge controller may only work properly with some older equipment, but that's remaining to be seen. So for now, I'm gonna probably solder it back together and put it in its original shape. And then, first, of course, I will reverse engineer and create a schematic, because I'm very interested to see how it's all arranged here. And not that many elements right there, by the way. So the schematic will be probably quite simplistic. So let me reverse engineer it quickly, and I'll be back with you. Alright guys, finally I have found some time in order to reverse engineer this guy. So as you see, it turned out to be not what I thought it is. I thought this is TP4056 charging controller, but it is not. I thought this is DW01 or something, this I forgot the name of the chip, that used everywhere protection, but it's not. It is XB5353A, which is not what I thought it is. But here we are. This is tiny guy's protection chip. This guy is a charge controller. Schematic, as you see, is extremely simple. So we have USB in, it's right there. We have a capacitor C1, which is right there under this the rubbery thingy, which is essentially a light guide for those LEDs. And here are the 4 LEDs, and this chip clearly has capacity of indication. So 3 pins of this microcontroller is to drive LEDs to show the level. Then you have the controller itself, charge controller, and the charge controller is, I already printed out some specs right there, pretty simple specs right here. So it is 2.4 amp synchronous boost converter and 2.1 amp charging synchronous switch, 96% efficiency, 97% charge efficiency, blah 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 blah. Docs I'm gonna be sharing with you for sure, and the typical schematic just right there, which is quite similar to what I whipped up. And as you see, even 3 capacitors right here is pretty similar. Actually didn't even realize that now. Except this circuit is missing here and some other things are not here. Interesting, yeah. Looks like this resistor and capacitor is not here at all. So yeah, that's funny. Oh yeah, actually they might have been here, but there is some unpopulated pins. Maybe they just skimped it. Okay, forget about that. So it's from the company called Untitled Technology. So what actually so far so good. This guy is really good for what he's doing. It's even actually, for my opinion, it's better than TP4056. So the protection chip. So there's another cheat sheet from Xusemi XB5353A. High integration, blah blah blah, solution for LiPo batteries, battery protection, advanced MOSFET, voltage detection circuit, ultra small package, blah blah blah. So it's charge reverse protection, protection of batteries, cell reverse connection, blah blah blah, power MOSFET, small package, 1 capacitor required. Seriously? Oh wow, here's the typical schematic. So yeah, it's only 1 external capacitor required. Over temperature, over current, 2-step overcurrent detection, charge detection, 0 battery charging function, so it can probably charge completely drained batteries. Delay time, high accuracy voltage detection, low current consumption, la la la. Actually, it's even it's actually better than DW01, I think. So I like this. I like this little board now. After I reverse engineered, I thought this is Chinesium to the hell of it, but this battery turned out to be almost 2500, turned out to be 1900, which is great. Otherwise, usually they are 5 times less than they are claiming, so this is okay. So technically I just can plop it all together back and shove it in the same case I got it, and it just and just use it. And clearly this thing can do more than 1 amp they claim here. It totally can do 2 amps output. Oh yeah, and this little resistor over here, and the switch is actually for just to show the level. If you actually I don't have it printed out. This little switch with this charge controller has actually quite many functions. So if you press it, it does show the level. If you press and hold it for 2 seconds, something to this extent, it shows it's resets or something, I forgot. But if you press and hold it for a long time, it's actually turned the light more than 4 seconds or something to this extent. So yeah, it's fancy. But in this particular case, we do not have flashlight. So here's the typical schematic right here of this guy with this LED right here, which is actually a flashlight, which is kind of, yeah, whatever. But I can turn it into flashlight actually. So if I plop some decent LED here, somehow make a hole, and yeah, I can turn it into flashlight. So guys, what is this? Ah, it's a little button. So guys, this is gonna be it. As you see, I will share this PDF with you and on my website if you are interested to see and to, you know, to play with this little charge controller board I got of Dollarstore for 4 Canadian dollars. Yeah, be my guest. I think this one is actually a little bit more useful than I thought it going to be. Still 1900 milliampere hours turned into 5 volt with some losses, and then turned back into to charge your a cell phone or anything like that. It's gonna be piss poor capacity or amount of energy for modern phones. Yeah, maybe if you had like old school Nokia probably were consuming quite a lot as well, but maybe not, don't remember. Maybe if you have the old phones, yeah, because they were living for like ages of the single charge, that can work for you, but for modern phones, nah. Modern phones have like, I don't know, 4500 milliampere hours batteries for 5200 milliampere hour batteries. Battery is actually huge these days. So this battery is a joke in comparison, but I mean, it still works. It's still pretty good. So way better than the other Chinesium stuff I actually review on this channel. So you can take a look at my other cheap batteries reviews that I posted some time ago. They're gonna be in the links in the description. So thank you guys for watching, and see you next time when I'm gonna show you another Dollarstore miracle, and we're gonna together enter the wonderful world of cheap electronics. See you next time. Ciao.